All right, and we are live. Man, got a slow start to say. All right, all right. What's going on, everybody? It's your boy Kilo Loco, and today we are going to be working with the Flashcards app again. Recap on what the Flashcards app is. I work with my son on his homework every day. Well, during the week, and part of his homework is to do flashcards. He has a set amount of flashcards, and then they get added to as he continues to progress. And as opposed to using physical flashcards, we ended up creating this flashcards app that he has liked. I actually haven't gotten to use it with the latest functionality where you're actually able to have multiple decks, select the multiple decks. So this is the word deck, and then he goes through. Now, it's relatively simple. Last time we actually added the ability to add new flashcards like this, or add new decks, and then also to be able to add new flashcards like this. And then a flashcard only has like a value and then like a color. So that's where we're at so far. There's still things that I think I'm gonna add to the flashcards later on, maybe like being able to add pictures and stuff like that. Also, I want to be able to have audio playback. But today, what we're going to be focusing on is refactoring the code. Because if we take a look at I think it's the content view that's still in there. Yeah, the content view. So content view has all kinds of stuff just all in it, right? I tend to like to get the functionality working for the app, and then I go back and refactor it. Because I'm the type of person that needs to see something happen to stay motivated to get it moving. So that's where we're at right here. We have some of the dummy data. All this data can be deleted because it's already been added to the backend. Yeah, and we just kind of need to refactor some stuff. Like I had mentioned, we're going to be using Point Freeco's Swift Composable architecture. And yeah, let's go ahead and start getting that implemented now. It's been a while since I worked with it, and there is a high learning curve for it. So it's probably going to be a lot of struggling during this live stream. I'm not going to lie. Also, I wasn't able to wasn't able to fully understand how everything worked last time I was working with it because I ran into an issue where I felt stuck. So we'll try to get through any issues in this live stream as we continue to build out the app as well. Let's go ahead and start adding this to our project. Also, if you have questions, feel free to ask them. Why it's a live stream so I can hang out with y'all. All right, we got Smile. Smile says, I'm really struggling to choose between front end JS or iOS native development. What do you advise me to do, or to choose? Really like Apple ecosystem, but people told me there is more opportunities in web. So it kind of depends on what you're trying to do. Statement that you made, the statement that you made where people have told you that there are more opportunities in web is true. There are a bunch, like the web development market is extremely plentiful. I think front end web development is probably the most plentiful job market, I would say. At least um at least that's the appearance or that's the perception that I have, because there are so many web developers. Um but overall, what I would say is both of them are great fields to be in. Both of them pay very well. Both of them have a lot of jobs. And that you should choose what you're most excited to do. I started out trying web development. I didn't like it at all. I did not like using JavaScript. So I would say Go with what you want the most. So like if you want iOS, but everybody's telling you to do web, just do iOS. Like if that's what you're passionate about, because that's what's going to be able to get you through the roadblocks. Because you will run into roadblocks where it's like all day you spent on the same problem and you can't figure it out. So if you are doing this with a programming language that you don't particularly enjoy, if you're making apps, web apps that you don't necessarily care for, then you trying to push through that roadblock is even harder, because now you have to fight yourself to do something that you don't care to do with a problem that you don't know how to solve. So that's why it's most important to do what you feel is most enjoy, like, yeah, what you enjoy the most, because that's what's going to help get you through those roadblocks. Pay wise, they pay relatively the same. I think you can actually get paid. Yeah, I think you could get paid relatively the same. I want to say that you might be able to make more as an iOS developer, but I'm not. I'm not going to stand on that. So pay wise, they're relatively the same. And then also depending on where you live, uh, you might live in an area where there may not be nearly any iOS development jobs. So depending on where you live, you may be forced to do web development unless you can find a mobile, like mobile okay iOS development job, or if you're willing to move to work for that job. So keep those factors in mind. But at the end of the day, I think the most important thing is like what you enjoy doing, and you pick that. What are the benefits over MVC or MVVM? Um, Honestly, MVC and MVVM, they seem relatively the same in my opinion. When I've architect, like when I do my design patterns, the way that I actually do MVC, and I usually only do it for UI kit because it works a little bit easier that way. MVVM is practically MVC, like if you do MVC properly. People will say that there's more, it's easier to test. But at the end of the day, model, view, model, you're still working with three components of the app. And whenever you have like three different components that are the primary focus of the app, it's practically all the same stuff. Honestly, just go with what you're most comfortable with and what's going to build faster, because that is like the least of your worries. Um, as you'll see, learning a new architecture is difficult, but it's only difficult for a couple of days. And once you're in that code base, you'll figure it out. All you have to do is just follow the existing patterns. This entire fight that iOS developers have over architectures, like every platform has its fight over different things. iOS developers choose to fight over architectures. Web developers fight over the different UI frameworks, Vue.js, Angular, things like that. Android developers fight over the dependencies that they inject, like dependency injection, and the different packages, like for all kinds of different things. But yeah, anyways, iOS developers fight over architectures. They're not that important. They're not that important to memorize, I would say, because regardless, no job should reject you because you don't know a specific architecture. All architectures are handled differently. Every MVC architecture or design pattern that you see implemented will be different across almost all projects. Same thing with MVVM. There's no one way to do any of these things, even if you choose the same design pattern. I'm sorry, I meant composable architecture, MVC. The thing that I like about the composable architecture is that it's unidirectional data flow. That I personally like. I mean, there's benefits that they'll argue for, again, testability and stuff like that. But I do like the unidirectional data flow and all the data being in one spot. I like that concept, but the implementation is much harder. All right, guys, let's get into it. All right, I think I added it. We're gonna look at the documentation to see what they recommend doing first. It's been a while, like I said. Um, so yeah. In short, the composable architecture is built off of events and states. Oh, this is another thing. Like you can rebuild the event chain that has happened. Um, because everything is an event, and you can just recreate scenarios for your app and the navigation and all that stuff through the events. So if you wanted to show a specific screen and a specific amount of steps, like all that is handled through the events, and you just apply the same events. I live in a country where there isn't a lot of iOS jobs. It's mainly Android, but in the same time, there isn't much iOS developers. What do you think of remote jobs? I do a remote job, so I love remote jobs. Remote jobs are hard because you have to um, deal with not being in a working environment unless you're going to actually like go to like a co-working space. But yeah, I like remote jobs personally. Okay, so what I'm going to do, because I don't really know how to get started, is I was creating this app and I was using the composable architecture. So I'm just going to follow some of the steps here to get us started. So um, you'll see that we have, where's the app object? So this is the app object. You see that I have this root view. I was using Amplify as well. So we configure Amplify first, and then it goes into this root view. Let's go ahead and kind of copy this root view and see if I could start getting some of my muscle memory back from working in this project. All right, so we'll have a root view. And I'll do a side by side so I could like copy and code. I could just copy it, but I want to like try to start remembering how some of this worked out. So first, import composable architecture. And there's like a lot of boilerplate that you have to get set up to work with the composable architecture. But after you're done, it kind of flows a little bit better. Root store. So now we need to create that root store with a view store like that, and then we do store stateless and do this, and then we'll go to, right now it's our content view. So we want it to go to our content view, but first we have to create this root store. So let's take a look at what root store is. I would assume that I would have put it in here, but apparently not. It might be under shared. Let's see. Probably be under shared. Interesting. Oh, root composites. Okay. Okay, so there's a lot of different things that you have to build. There's a lot of different things that you have to do in order to make the composable architecture your thing and work. We're going to actually do all this in here, and then I'll refactor it out into a second one. But you'll see that this root store is actually of type store, root state, and root action. So first we need to have a root state. So this is the different states that hold like all of our data. So this would be like something that holds, like you can see here, navigation state. So that's one thing that we need to have. And we can start with that. So let's start like adding all of these in. What do you think of indie app development? Is it hard to get into? Indie app development is not hard to get into. You could be in indie app development by the end of today, or by the end of the hour. because it's just you making an app. I'm technically doing indie app development right now, right? So, yeah, making a living off of indie app development is a completely different story. It's tough. It really comes down to what you need to happen. Like, are you looking for a job because, like, are you looking into development and becoming a developer because that's what you want to do, like as a hobby? Or are you looking to switch careers and you need to support yourself because you already have responsibilities and things like that? You need to be able to figure out all of that stuff. And if you're looking to switch careers and start making money right away because you have to pay bills, indie app development is not the way to go. Indie app development generally tends to happen on the side. Like if you want to make your own apps and make money from those apps and then live off of those apps, what you have to do is you have to work at another job and then you do indie app development part-time until your app starts bringing in revenue. Almost all indie app developers have to supplement their income with like either working at a 9 to 5 or doing part-time work by doing like contract work. Almost all indie app developers have to do like some type of contract work to support themselves. It's hard to have an app be popular enough to pay all your bills, especially if you're in this mindset of being a developer that makes you know, a a pretty good income. So if you're living on 6 figures and you want to become an indie app developer because you're already an iOS developer like that or something like that, yeah, becoming an indie app developer isn't going to make you 6 figures not right away. You might be able to build an app that will make you a millionaire, but it usually does take time. So unless you have savings, usually you have to work at a real job. Not that indie app development isn't a real job, but like you have to work at a job that's going to pay you consistently until your app takes off. All right, let's go ahead and start building out some of this. So we have our root state, waitable, eatable. Let's also add in our navigation state because that's something that's like a feature that we actually already have in the app. Navigation navigation state, and we're making all of this equatable because that's how we will know if something has changed. It'll make more sense once we like start doing it, but this will be route. We already have a route object, as you can see here. So create new event. That was going from the events page to be able to create a new event. Let's see. Now we have routes. And what I want to do is I want to pull over the routes. Oh, do we actually have a route? I don't think we actually have a route. That's what it was. Oh, it's already in its own thing. So, okay, so I'll leave it here, but as you can see, we have deck. So we have deck and then we pass a wire deck and then it goes. May change that, not sure. But we already have that. So going back over to our root view, we have our navigation state, and then in our root state, we want to create a navigation state like so. So if we take a look at our root state, right here, we have this navigation state variable. So we'll add that there. So var navigation state is equal to navigation state. Also, while we're talking about all this, what app did you like making the most? Well, I don't know what I would say to that because like obviously I work on like a lot of different little apps and I don't publish a lot of them. A lot of them just kind of stay in my own usage. Like I'll just use apps. I don't necessarily publish them because I don't like maintaining them. And then once their use case ceases to exist for me, I just leave them. They just die. Um, this is store. But one of the apps that I did like working on the most was the Bird app, which is the electric scooters. And I liked that because I was working on a team full of like 8 other iOS developers and I was learning so much when I was working there and it was fun. But also like I got to see a lot of different implementations on how to write code and I actually borrowed some of that information that I learned where if you take a look at the models, you'll notice that these are called wired deck. So it came over the wire, it came from the internet. And then locally, I'll be working with a concrete class. Well, this is a concrete object as well, but I'll be working with a different local object. And this idea I actually got from the Bird app. So I'd say probably the Bird app was the one that I enjoyed the most. Okay, so we have our root state. We need to have a root action as well. Enum action. So stores consist of 2 different things. They consist of a state and an action. The state is its current state, and then the action is what will modify that state. So that's what we're kind of going through right now. Navigation action, like so. And then we want to pass in a navigation action. So navigation action is its own like its own thing, and I only had 2, so it's also an enum. Do it enum action. Like I said, a lot of boilerplate to get up and running with the composable architecture, but after a while, like after you get that foundation set, things start going a little bit faster. So I have one action which is to go to, and then you specify the route. The other one is to update routes, and this was like if you wanted to, this was beneficial because if you wanted to hop back like 2 screens, you can just do pop. You can do pop on the last 2 or something like that, or you could pop all of them and then empty the array, and then that will send you all the way back to the root of the stack. So that's why I had the update routes like this as opposed to a go back. This one was actually a better idea to use like functionally. All right, so now we have our root state, our root action. From here, I like to make type aliases like so. And you'll have this root store that is part of the root view, or that's passed to the root view. So we'll do a type alias root store, and it is just a store that has its generics filled in. So root store or root state and root action like so. So now we have that aspect all set up, right? So that creates our store. The other thing is the reducer. So the reducer is where all the logic is to make the decisions on what's supposed to happen in the app. It reduces all the actions back to one source, updates the state, and then that's reflected throughout the app depending on what's going on. Let's see. I really like Swift. Find the language really elegant. When I see the web, it's so overwhelming with so much text and choices. Where do you see the future of iOS mobile development in the next years? iOS mobile development is not going anywhere. Native development isn't going anywhere. You have to have native development, especially on iOS, where it's like that. It's all controlled by Apple. So Swift development is going to be here the same way that Objective C is still here. Excuse me. Let's see. Yeah, Swift is the only reason why I still do iOS development. Well, and I do like the iOS operating system, but Apple, in terms of Mac OS, I'm not really happy with the way that they're going. I don't particularly like the way that Swift UI is set up. I honestly prefer Flutter, their UI, APIs. They actually have stuff that is relevant to mobile developers. I don't know what's going on with Apple. I don't understand why Swift UI is so difficult sometimes. If you play with Flutter for a little while, you'll see that they have much better APIs than Swift UI. Dart's a good language, but I prefer Swift. Swift is a much more elegant language. It's my favorite language to code in. Um, but yeah, iOS development will be here for a long time. And there's only more Apple devices that they're going to create, so keep that in mind too. If they decide to launch something like glasses this year, none of the other stacks will have that for like 2 weeks. So if you wanted to try to make an app within those 2 weeks to support that operating system, you could potentially be the first one. But they tend to catch up pretty quick. So initial state. This I don't know how to do. See. Reducer. So we need a reducer. We need this reducer. And then we also need this right here, this root environment. I don't think we need the system environment. I didn't find it particularly useful when I created it. So we'll just go with a regular root environment, which is just an empty structure, which could be used to pass things like kind of like dependency, like as dependencies. So let's go ahead and create this root environment, because that's how you make a reducer, is that you have a struct represent it. Root environment like that. No dependencies that I need to pass into here. So it's just kind of like a placeholder really. And then we create our reducer. I decided that I like doing type aliases when working with all this. It makes everything easier to read when you're at the call site. Reducer. This is of type reducer. So they've changed it. Root state. Root action. And root environment. So right, so it looks like reducer is now deprecated. So they said in favor of the reducer protocol. So let's go ahead and do that. Is there a fix for it, or okay? Any reducer? I kind of want to see what happens if I wanted to make a reducer protocol. So let's go ahead and router 2 is of type reducer. Reduce protocol. So let's see what it asks for if I do this. Okay, well, let's take a look at it. Associated type, state, action. Okay. Interesting. All right, let's take a look at this because this is something new to me. I have to figure it out. Unfortunately, this is going to be kind of dry. It's a dry process to go through refactoring stuff, especially if you're still learning. So I apologize for that. May not be the most interesting thing on the planet right now, but at least y'all are asking some interesting questions. So when you were an internet bird before full time, were you an internet bird before full time? No. I think I was lucky enough to I was not an intern. I got hired. But I did get hired like at the lowest level as an iOS developer because I didn't do well on the interview. Like I'm a really bad interviewee. So I didn't get hired like at a senior level or anything like that. I was at like this stage to where I was going to be, I guess, reconsidered for what my level would be. I was only there for about 6 months and then COVID hit and then I got laid off. But yeah, like I was not I was kind of like, I guess I was kind of like an intern, but I was getting paid like a regular developer. I was getting paid more money than I had ever been paid in my life at that point. So I wouldn't say an intern, but my official title wasn't like settled. And I came in like as like a entry level iOS developer, which was still making really good money. So yeah. If you were to start over from scratch, would you use Flutter Native, something else, or a combo of Native and X? iOS development is still the easiest to get into, in my opinion. There's no crazy weird setup. That's one thing that Apple has done really well is you can't code anything. You can't code anything. You can't make an app, whether it be a web app or a mobile app, cross-platform or native, easier on any platform outside of iOS. You literally go to the built-in app store on your Mac computer, you download Xcode, and you start writing code. It's literally the easiest platform to get started on coding. Would I still choose it? Yes, and it's for two reasons. One, because I love the Swift programming language. It's my favorite language. I still feel it's the most elegant. Some of the changes over the recent years, I'm starting to like not like it so much. Like there's some weird things in the structured concurrency. There's some weird things with the property wrappers that I'm not really that stoked about. I think that the language was much more elegant around Swift 3 than it is now. But the things that we're able to do in Swift have come a long way and they're really nice. But I feel like it's not nearly as elegant as it used to be. I would still choose iOS development because once again, it's easiest. iOS development community is very welcoming. A lot of people really love the Swift language. A lot of people really love iOS development. A lot of people are really loving of that Apple ecosystem. So yeah, I would still choose iOS development. But again, Flutter does have the better APIs. It's easier to do there are widgets for the things that you want to do in Flutter almost always. And those are native widgets. It's not like you have to add a different package. They're like native. So I would always go with iOS still, which is why I choose it. Flutter is my second, and then Android is my third, because there's always something that I run into on Android. Like I could make the same exact project day after day, and I might run into a different problem on the second day than I did on the first day. And it'll just be like because Android Studio had an update, or I forgot to like update the specific package, because I'm always working with like one of the latest. So if you're not using alpha on this and then beta on this, then it's not going to work. See, mobile development target more end users compared to web that target more business. Yeah, possibly. You know, when you're making a website, it's usually for businesses, right? So, but those businesses generally need to include people. What's going on, Eugene? Long time no see. Good to see you, man. Thanks for joining. All right, so let's take a look at this reducer protocol. It looks like they want us to do things a little bit differently, which is okay. So a protocol that describes how to evolve the current state of an application to the next state given an action, and describes what effect task should be executed later by the store, if any. Conform types to this protocol to represent the domain, logic, and behavior for your feature. The domain is specified by the state and actions, which can be nested types inside the conformance. So this is how they want us to set it up now. The logic of your feature is implemented by mutating the feature's current state when an action comes into the system. This is most easily done by implementing the reducer protocol, reduce into an action method of the protocol. So here's your feature. You would reduce into this state, it's an in-out state, and then the action, which is going to affect that state, and then you get an output of an effect task action. So we switch over this action that's passed in. We have, let's say we have two different cases that we need to check. We want to decrement the count, or we want to increment the count. We modify the state of this feature, right? Because we have access to the state right here, or assume, let's see, yeah, struct. So it would have the state somewhere in there. This would be like a self.state, or oh no, it's passing it in the state. So it's going to update that state to in and out. And then we return none, because there's no effect. There's no additional effect that you have to chain to. So that's why you return none. The reduce method's first responsibility is to mutate the feature's current state given an action. Its second responsibility is to return effects that will be executed asynchronously and feed their data back into the system. Currently, feature does not need to run any effects, and so effect publisher is none is returned. If the feature does need to do effectful work, then more would need to be done. For example, suppose the feature has the ability to start and stop a timer, and with each tick of the timer, the count will be incremented. That could be done like so. So we have our feature, we have our state. We can see that it has a variable called count, and it's set to 0. There's 4 different actions, or 5 different actions that we could do. We can hit the decrement button, which is going to do something. Obviously, it's going to do -1, increment +1, right? We can also start a timer, right? We can stop a timer, and then we also have to account for when the timer ticks, because it's probably going to update the UI, right? Now, this is like the really interesting thing about the composable architecture. And I see Smile that you have a question. I'll get to that in a bit. But um, the interesting thing about the composable architecture that I really like is that every single action in the app, anything that a user can do is listed out, like every single thing. If you need to refresh the page, if it's like if you have to do an action after an action, even if it's not like directly user generated, it is inside the app, like, and it's listed out. This is what this app can do. And this is like a really interesting thing that I really enjoy about it. So we have this timer ID. This I never fully understood, but it gives there's like it needs like a type. It needs to have like this unique type. I can't remember exactly how it worked, but yeah. So we have this action, right? And these are the same, right? Decrement, increment, those are the same. But what happens if we had start timer, right? So when we start timer, then we're going to run some code. And this is, as you can see, like while true. So this is like forever. And then, let's see, we await, task, sleep. Okay, so we are sleeping. And that's an interesting one. So it's pausing, and then it's going to pause for 1 second, and then it's going to send the timer tick. So that's going to essentially create this timer after it awakes after this 1 second that it's waiting for. So this is an interesting way to do it because that would like freeze up your UI, I think, but whatever. Um, yeah, I don't know. And then and then it's cancelable. So this is where that timer ID thing is used. I still don't fully understand this part, but I know that you have to have like a cancelable unique object there. Stop timer, and then you cancel you cancel the same thing with the by this object type. So I think it like references like the object type, and then it cancels that specific thing. And then you can see like the timer tick is just going to increment the count. Similar, it may have the same functionality, but you want to classify it under something different to represent that action. One second, guys. Okay, so let's see. So we're going to implement reducer protocol reduce. For some reason I thought I saw body. That was weird. Okay, so what I want to do first, and obviously this is taking a lot longer than I thought, but we want to implement this feature, so it will actually be the root feature, I think. So let's call this root feature. And then we want a state and an action. Let's see. We already had the state, right? So our root feature is going to have a state var, or what is it? Struct state. And we want to have our different states. So our state is going to be a little bit more complex because what we're going to do is our root state is going to be this right here. So now I guess what I would do is I would actually use this instead. And let's see. State cannot be nested in protocol root feature. Oh, what type do they use? It's a struct. That's what it is. There we go. That'll be our state. Does not conform to. Okay, well, let's fix that. Action. Let's see if we're supposed to do struct action. And we have our root action, which is to have one of these cases. Paste it in like that. Now the body part I didn't see. Are you using UIKit or Swift UI at work? So this is my work. Like I like create content and then work with Amplify and then try to find the different use cases that developers are using for Amplify and try to make sure that there's content to support them on their way. So I use Swift UI primarily. I haven't touched UIKit in a little while. Okay, so let's see. We have body in here though. That's the part that I'm kind of wondering about. Body. This is interesting. Let's see. Oh, and there's a lot of them too. Or you can implement body. You can either implement reduce or you can implement body. Okay. This is interesting. Okay, let's read this because obviously I don't know what's going on. This is the basics of implementing a feature as a conformance to the reducer protocol. There are actually two ways to define a reducer. You can either implement the reduce function method as shown above, which is given direct mutable access to application state whenever an action is fed into the system and returns an effect task that can communicate with the outside world and feed additional actions back into the system. Or you can implement the body property, which combines one or more reducers together. At most one of these requirements should be implemented. If a conformance implements both requirements, only reduce will be called by the store. If your reducer assembles a body from other reducers and has additional business logic it needs to layer onto the feature, introduce this logic into the body instead, either with reduce or moving the extra logic to a method that is wrapped in reduce. This I'm not really that familiar with, so I'm going to go with the one above, which is this reduce into. Okay. So let's go ahead and add in that function now. Reduce into. It gives me the function, the method signature. I think this should be done. There we go. We switch over our action of our case navigation action. Let action. And then what it's going to do is it's going to update the navigation state. And you have to also keep in mind that this navigation state has a navigation action, which has two. So what we could do is we'll just do it like that, and then we'll do another switch statement on the action. we'll call this one nav action. And I actually have to get ready right now, but finish this nav action. We have the case and we have go to, let route like this, and case update routes like that. So then we would actually access our state dot navigation state dot routes equal to routes, or it would be state dot navigation state dot append route. There we go. So as you can see here, we have our root feature, has our state, it has an action, and then it has its own reducer. I'm gonna have to leave it right there because I have to go and head over to go get my son, and I still have to get ready. But we will continue refactoring this code into the composable architecture tomorrow, and hopefully we can actually get more done. Has an app of yours ever been rejected by App Store? Yeah, multiple times, a lot of different things. But yeah, if you have more questions, you can feel free to hit me up on Twitter. But yeah, multiple times. Don't worry, you're not the only one. All right, guys, thanks for joining me here today. We'll cover more composable architecture next time. Go out there and keep coding passionately.